I would like to introduce Remi Demerle, who will lead the discussion on smart utilities. Welcome, Remi, and I'll give you my microphone.
Okay, this works perfect. Thank you, Susie. So it's a great pleasure to be here in the LoRaWAN World Expo. I'm very delighted to welcome our guest panelists I will introduce. The topic of today is about sustainability, profitability, and resilience for smart utilities. This, of course, combination of keywords looks like a puzzle game. How can you combine sustainability with profitability? That may always seem strange to reduce consumption when the purpose is to make billing. It's also a paradox, apparently, to have better networks, better infrastructure for resilience when the sustainability is at stake. Population grows, cities are over and over populated, and still the lack of resources is a problem. So shall we produce more, but can we do much better for management of existing resources? There are those being a question behind the topic of today. So just a few words about the guest we have today. Myself, I'm Remi from Semtech. I'm the chairman of the Smart Utilities Workgroup in the LoRa Alliance, which include more than 130 members. We have activities to sustain awareness, use case, to create digital content, to also create webinars, and of course, activities like that. Events, for example, are important. But also we try to catch new use cases and to sustain then specification work by the technical committee. So there is an effort made by the LoRa Alliance to help utilities to benefit more of LoRaWAN. So it's my pleasure to welcome Fabrice Strevens from Elvexys, Erwin Guizouran from Evolution Energie, Gregoire Landel. I think, okay, I'm back. I will ask you each, in that order, Fabrice, Erwin, and Gregoire, to give few words about the company you represent, and then after we will go into the topic.
Thank you, Remi. So Fabrice Strevens, working for Elvexys. We are providing solution for utilities, for energy utilities. We are operating since 20 years, and currently we are using LoRaWAN technology to monitor the distribution grid, the medium voltage distribution grid. We are not speaking about smart metering in what we are doing, and monitoring the flow of energy going from high voltage substation to your houses.
Hello, I'm Erwin Guizouran. I'm the CEO and founder of Evolution Energie. Evolution Energie is a company that I founded 12 years ago with one goal: try to offer initially to very large consumers and infrastructures an all-in-one energy management solution that could help them pilot both from a technical standpoint, their energy and usage and production, but also from a financial approach, how much they can be profitable with this energy. Thank you.
Hi, I'm Greg Landel. I'm the CEO and founder of CityTaps, and our vision is running water in every home. We work with LoRa to propose and offer to water utilities the world's only smart and pay-as-you-go water meter. So it's a smart meter, which I think everybody here knows what that is. And it's a pay-as-you-go solution, which means that a person will pay in advance of consumption, and then while they're consuming water, their credit will be decreased, just like the old telephones that we all used to use in the early days of mobile phones. This has a huge advantage for people who are very poor and who have trouble paying large bills at the end of the month. It's much easier to pay €1 a day for 30 days than 30 euros all at once, for example. It's also a huge advantage for the utilities who serve them, the water utilities who serve them, because they get to collect the money that they're owed in advance, and therefore they can actually do things with this money, which in the financial constraints under which they operate is essential to ensuring that everybody can have water at home. We have a second line of devices and software, so we offer everything from the device to the software, including the connectivity through LoRa, which is on the non-revenue water side. So we look for both leakage and what is politely called commercial losses, which is really theft and underbilling of water through poor metering. So there you go. That's the two things we do, all in the objective of running water in every home.
Thank you all for the presentation of your activities. To get deeper to the topic of today, could you give an example of a real application of LoRaWAN to support your solution or application, in which country, for how many devices, some key results you got from this example of a story? Can you provide one?
So we currently have about 3,000 devices deployed in 11 different countries, ranging from Ecuador to Singapore, and ranging from Senegal to Djibouti and Namibia. So we work exclusively in developing countries, except for Singapore, for a number of reasons. And so we provide, our solution includes natively the LoRaWAN connectivity, because it's the only way that a water meter can last a sufficient amount of time, which is to say about 10 years, and operate in a bidirectional manner. So GPRS can work in bidirectional manner, but your battery will be dead in 2 to 5 years. Other things like Sigfox, I know it's probably impolite to name them here, but they don't work really bidirectionally, or at least not in any way that actually makes any sense. And that's why we chose LoRa. It's low power, which is very important in the water sector. It's very cheap to deploy, which is very important for the water utilities who don't have a ton of money. And it allows this bidirectional communication, which was essential for us to be able to do the complex math that is required in order to implement the step tariffs that are implemented by water utilities. Unlike a solution where, in our case, the calculation of how much you still have on your account is done in the cloud, and that information is then transmitted to the meter on a 30-minute step basis. So you can see that having the ability to go downstream is absolutely essential to being able to have a functional solution that applies the step tariffs that are most often chosen by water regulatory bodies to charge customers for water.
What you want to describe is the difficulty to bring water access to population based on the difficulty to have a step tariff applicable in the deployment with endpoint of water meters. How do you cope with that problem where the water utilities cannot serve customers that are not able to pay for this tariff?
So in fact, for most people, buying water from the water utility, or I should say buying water service, because you're rarely buying the water itself, you're just buying the service, the fact that it comes to you, is much, much more affordable than any other alternative, 10 to 100 times cheaper than buying water from a delivery service, or from digging your own well and then paying for diesel for the pump, or having a tanker delivery to you, or whatever these alternatives, or spending time walking to the end of the street and then walking back. That also has a cost. and it takes time and it's difficult, and you usually end up consuming too little water, right? So the ability to afford enough water at a regulated tariff that's decided by the government, therefore can include cross subsidies between large and small customers. That ability is essential to our business model, and those are the people who benefit at the bottom of the pyramid. Of course, none of these people can benefit at all unless the utility is collecting the money that it's owed in order to provide the service, and therefore has the funds to operate the machines and the power plants and the treatment plants and the pumping stations, and to pay for the electricity, of course, that powers this whole thing. It's very important to realize that drinking water is an industrial product that is delivered straight to your house and that you consume. It's not something that most people ever think about, but it's very much like if you had a tomato sauce delivered to your house every day. You would never think of the fact that it just falls from the sky. You would expect it to be made in a factory, or at least in somebody's kitchen. In our case, the drinking water that you consume has been made in a factory, delivered through pipes, which are all monitored by a variety of LoRaWAN devices, by the way, and which we can then integrate into our management suite, which is the other thing that we provide.
And so to catch the solution you propose, which is a pay-as-you-go for water clean access, you help the utilities to re-onboard customers who had difficulties to pay the bill. So as you say, they get credit and they pay on the long-term basis. But how do you adapt this situation between the capacity of payment and the supply of water by the utility?
So the supply of water by the utility can be a problem, right? Which is why we've extended our services into non-revenue water solutions that include the detection of leaks and, of course, then the ability of the utility to fix those leaks. The idea is that without producing any more water, without building new treatment plants, you can serve more people with the same amount of water. So that's an essential element. In terms of people's ability to pay for it, we have noticed that even in places like Niger, even people who make significantly less than $1 per day or $5 per day for a family, which is the bottom of the bottom, these people are completely able to afford piped water at home, that they end up, in fact, being the utility's best payers because they pay in advance, and that the utility has no incentive at all to disconnect them. Quite the opposite. And not only that, but when these people had gotten themselves into a financial hole with the utility, when they ended up owing the utility money, for example, they owed 100 euros in debt, which is an insurmountable amount of money for a family making $1 a day or $3 a day or whatever, they were never going to dig themselves out of that hole. And our solution, because of its bidirectional communication protocols, because of the sophistication of the software that we built, lets these people repay their debts in micro payments that would be completely impossible to collect by hand. So the integration of software, hardware, and communication makes for a sustainable solution by the utility, makes for a profitable solution by the utility, which, as vexing as it may be to some people to hear me say this, is the key to resilience by the water utility. And the fact that you and I don't die from cholera and diphtheria is because we have sustainable, profitable, and resilient water utilities serving us every day, 24 hours a day, including at midnight on Christmas and New Year's Eve. And we never ask ourselves, are these people going to go out of business? Right? So in some ways, we've decided that the key, the end problem was the finance water nexus, to make sure that there could be water flowing in one direction, money flowing in the other, that the money was payable in ways that was easy for people, including the poorest, and collectible in ways that was easy for the utility.
So it's a clear example of how the IoT can have a good impact to solve this problem, because water is available. There are water treatment, there are production of water by water utilities in those countries, but they had a gap to fill in between the endpoint and the capacity of people to pay the water bills.
The manner in which people paid, right? That was the thing.
Yeah.
People, in fact, have the money, but because they tend to have irregular incomes in some cases, the ability to keep it and pay it all at the end of the month was not there. Was the ability to pay it on a sliding basis or on an as-you-go basis was is there.
Thank you, Gregoire. To continue with the, I would say, understanding of use case application you have performed, achieved for enterprises, utilities. Do you have one example, Erwin, you could share?
Yeah, I can share with you. Like, I would say a quite striking example in France, because most of the people who are non-local here passed through the Paris airports, Orly, Roissy-Charles de Gaulle, or Le Bourget. This is an example of what can be done in terms of sustainability, profitability, and resilience, and with LoRa solutions. Right? When we talk about energy efficiency, energy consumption, I would say it's a big word, but if I want to compare my energy efficiency between this month and the previous month, no, I just don't need only my energy metering data. I need to know what was the outside temperature. I need to know what was the building usage. I need to know a lot of items. And that comes through a lot of different types of sensors. So if you really want to go into knowing your energy, I would say not only your energy bill, but your usage of energy, you need to be really aware of what it means. And that's what we implemented with over 100,000 devices. So it's huge, more than 100,000 devices that were implemented indeed by our customer. We provided a software solution around that in order to monitor each building, each office, each warehouse, each, I would say, also their cogeneration, the parking slots, and so on. And it helps them by crossing this data, knowing that, okay, I thought my energy consumption in this parking was normal, but I did not know that there was nobody in this parking because it was not used. And it was not used for months. And that really created a profitability gap because they were just paying for nothing. In terms of sustainability, that was a waste of energy. Today, we cannot waste energy. That's the first point. So first, make sure that you are able to compare a hotel with another hotel. You say it's simple. Yeah, in a way it's simple. You take the energy consumption of the hotel, the number of square meters, the usage of the rooms, and more or less the outside temperature. If your hotel consumes twice the energy consumption of another hotel, you have a real issue. So it's really easy to first make these computations. Then you will check your bills. You will also, by installing sensors, personal metering devices, be able to bill back the energy. Why? Because if you pay your energy per square meter used, it's like in, I would say, a lot of residential buildings in Paris. Yeah, then you, I would say, you or your neighbors will have a tendency to use a lot of water by taking baths every day, and to consume a lot of energy as well, and even to open the window to just cool down. If you pay per usage, you really reduce your energy consumption or the energy consumption of the tenants by more than 30%. Because when you have to pay the bill, when you see the energy consumption in euros, I can guarantee you the impact is completely different.
So you're describing that the use of IoT is to collect data that help enterprises to estimate or ready to calculate, to measure what they consume and how they can compare with others. It requires a unified model or a unified methodology to make a fair comparison, right?
Right. These methodologies do exist. Like it's ISO 50001 with IPMVP methodology. But the point is, most of the time they were used by, I would say, consulting people once per year doing Excel files. It's not real time. If you want, you have the choice. Either you want the real-time movie or you want the snapshot every year. And when you want the movie, at the end, you want an 8K screen and you'll be able to see all the pixels with all the details. That's where our customers are achieving in terms of sustainability. They know the details and they can act.
And according to your success, the effort they made to have a constant monitoring is paying back with results in terms of saving of energy.
Yes, and they even they save more than 15% of their energy at an airport level. Their goal is to reach more than 30%. They also reach the scope 3 of the carbon accreditation report, which is the best ever. And they've been the first airport group in the world to achieve it.
Oh, great. In that, the spread of a new method and better tools to optimize water, energy, and perhaps also gas, heating, etc. Do you see also some utility companies or even smart cities trying to adapt better methods to change for good?
Yeah, completely. Especially today with the arrival of electric vehicles. Let's be clear, when you will have electric vehicles in cities that will replace thermic ones, you will multiply by more than 2 the electrical consumption of the city and by more than 5 the instantaneous power need of the electricity grid. So either you dig all the roads of the city, or you find clever ways to aggregate and to have an intelligent charging systems to predict, okay, there is a football match, the cars should be here. The people are going at their office, they might charge at that time. And so predictive charging and incentives to, I would say, charge on the long term or charge at night is something that is currently implemented, because flexibility used to be, I would say, on the transport grid, and now it's going on the distribution grid, because today every home has a risk in a way with an electric vehicle to consume like an industrial.
Okay, so this is a call for not only using data for monitoring and changing behavior, but also for predictability to help to support new load or to have a better balance between the demand and supply. That's, of course, a challenge for smart cities to have more and more electrical vehicles, scooters, buses, etc. Coming to this topic of electricity usage, you have, I think, a good expertise with smart grid. Could you develop and share an application you have deployed?
Thank you. Yeah, absolutely. And the example you have is just excellent, because we are helping our customers are utilities, and you can predict the high load, yes, but they are also willing to know what is actually happening on the distribution cable. And you can imagine, just to give you an idea here for the people here, when you have distribution network of electricity, we are speaking about a string or a chain of cables with small transformer substation and distributing from there the electricity to your houses. The energy utilities needs to know what's happening. Till nowadays, in many countries across Europe or across the world, it was no need and no interest to know what happens, because we were able, or utilities were able to measure from the input and say, if I put 100 here, at the end, maximum I have is 100. But nowadays, because of decentralized, because of solar panels or wind farm or things, energy is not only produced in one point, big factories, but along the network. And it's why there is this need to know what's happened, because you can have points where it's on the network, which is higher than the capacity. So it's why we use LoRa network to deploy sensors across the network to help utilities to understand what's happening, to better use the network, and to sustain the growth of electrification of the system.
So you're saying the addition of renewable energy is a challenge for utilities to have a better monitoring of smart grid.
Yeah, indeed. So they need to have better monitoring of the smart grid to support those new energy. That's really something important, because it changed the paradigm how the grid is used.
And about the resilience, I know that you have brought a product. You want to tell us more about this, but and each of you could have also a product to present your smart water meter too. But can you tell me more what this product does?
Yeah. So I took a product to give you an idea. So with this product, we can monitor easily the current flowing on 20 kilovolts cable with some Rogowski coil. And this product is connected. We provide at Elvexys the device, but also the LoRaWAN connectivities, and also the protocol conversion to be able to integrate the data to the data system, which means monitoring system. So with this device, we measure the flow of energy on those big cables.
So we have here a panoramic view of how the IoT can change positively the way the utilities supply either water, energy, or manage better their grid, network infrastructure. So it's always important to see that change with new value, new service, or better service for customers, optimization of processes, reduction of costs, and also capacity to capture new opportunities as the introduction of renewable energy, electrical vehicle, or capturing potential customers. So this is where the IoT can play a key role. To go a bit deeper in the sustainability regarding the climate change, can you share some examples of where you see IoT making a difference?
So in the water sector, as I said earlier, water is an industrial product. So it has inputs such as energy, chemicals, and of course the pipes that are needed to bring it to anywhere, and the pumping stations that need to be built. So there's materials, energy, and chemicals. When you increase the efficiency of the water network, specifically by reducing leakage, you therefore reduce by the same amount the amount of energy, the amount of chemicals, and the amount of the size of the pipes that are needed to supply a given amount of people. Now, of course, once you've installed the pipes, it's difficult to change them. So it's important to correctly design the network from the beginning for the targeted population. But in terms of the electricity consumption for the, that's needed in order to pump water to and from, and in order to treat the water, and in terms of the chemicals that are needed, which of course come very often over very long supply chains from China or from wherever, on boats, and so the impact of reducing leakage in water utilities is essential to improving the performance, the electrical performance, and the chemical performance of the utility. Now, unless you have data about where the water is going at what time, who's consuming it where, you will not be able to find the leaks. It's actually not easy to find leaks on a water network, especially when they're not visible from the surface. And it's more of an art than a science, honestly. But with the proliferation of sensors, and many of them are LoRa enabled because of the length for duration of the batteries, right? The energy consumption, and the proliferation of LoRa-enabled actuators on the network, the ability to close and open valves in order to isolate certain parts of the network. It's allowing the utilities to perform significantly better than they have in the past in looking and solving the leaks that are the key, literally money, energy, and chemicals washing down the drain.
So it's a clear call for more investment in solving the problem of water leaks.
There's an absolute need to solve the problem of water leaks for climate reasons, but also for so that there will be more water available to serve people. In the vast majority of urban environments in developing countries, the utilities are unable to provide enough water to serve everyone at once. And so they end up having to do what's called intermittent water supply. So suffice it to say that there's many reasons, not just climate change, to look for and reduce leakage, but it's definitely a key thing that needs to be done.
And you, Erwin, will you have some example to?
Yeah, we'll make a parallel with the water leaks. In electricity, you have electricity losses that are physical losses. The longer is the network, the more you will lose electricity. It goes on the ground. So it's nothing except earthworms, maybe. So the point is, try to consume and produce locally. You've heard that a lot for the last 3 years, but what does it mean? It means have solar panels, have batteries, have V2G electric cars, but most of all, have control of that and think at it as a system, both as an electrical system, which means prediction, for example, using your battery or your EV car or your water heater. You can use data with meteorological data, with satellite meteorological data, but also with 360 degrees webcam that will forecast the clouds passing on top of your house. Then you avoid, and you can predict, you will not avoid drops in production, but you can stabilize your usage and predict how you will use and ramp up your battery. The other point is when we talk about energy and self-consumption, now we also have to think about energy conversion. So using heat, cold, electricity, natural gas, hydrogen maybe, all of that has to be thought of as an entire energetical system. And it has to be optimized. And with the help of LoRa, it is possible because you will need a lot of data, you will need real-time decisions, and that can only be done with, I would say, integrated automation systems.
So you're describing a future, or do you have an example of this self-production system for homes or for, I don't know, a farm, for example?
I would say it's a future, in a way, but it's also a project we've implemented in Singapore on the island of Semakau in the project READS 5 years ago. A project we've implemented quite far in China, in the city of Hangzhou, in 2019 as Evolution Energie. And very recently, that's much closer, especially these times, we've set up the microgrid system of École Polytechnique in Paris-Saclay, which is the first ever microgrid in the Île-de-France area that controls all these items with a concern on self-consumption, self-production, and V2G. So feel free to contact me to visit it on demand.
Sure, and that's not very far from here, by the way. Regarding the impact on climate change, Fabrice, do you see some either a solution or can you share example?
Yeah, absolutely. So the utilities are very, very interested and committed to reduce their emission. And it's why when we are offering them a bit of monitoring, and especially with our solution at Elvexys, we can localize faults on the network. And that's helped them to, when you have a precise localization of the fault, they are able to send someone directly on site at the right place. Because without our solution or without monitoring solution, what they have to do is to go in every station to find where there is a problem. So that's one thing. They're able to, nowadays, thanks to our solution, to reduce the number of travel to visit and to repair problem. That's one thing. Second element, I said that utilities are interested to monitor the usage of their cables, their transformer, is for one reason, is to be able to push them to the limits to avoid change and to increase the lifespan of their equipment. Therefore, increasing the profits, because you can devise that instead of using 30 years, you use 50, you almost pay a second one. That's one thing. But and also to maximize, to avoid that installing new cables and to serve more customer because they know what's happening.
So to do this wrap up, we had a good example of how IoT combined with micropayment is a new manner to help communities and more people to get access to clean water with CityTaps. CityTaps is a company that is using LoRa since a couple of years with success in project in Africa with water utilities, 6 years. We have also a great example of how enterprise, Aéroport de Paris, and so on can have better tools to calculate, to estimate day per day their consumption and have a better impact. And with Elvexys, we have also the example of how the smart grid can be monitored with the LoRaWAN devices they have here. Example. The good reason for UT to do better is not only to reduce their cost, to optimize their processes, or to create value, or to serve better customers. It's also to have an impact for climate change, which I believe truly is where we go together with the ecosystem of LoRa Alliance. I want to thank you again and ask you for a warm applause for our panelists. Thank you.